Hi guys, welcome to Deep Learning Week, Introduction to NLP. I am Liangyu and today I will guide you through the basic learning of NLP. If you are seeking basic concepts and the difficulties in NLP at this moment, as well as its applications, you are coming to the right place. But if you are looking for very advanced topics, very fancy models, please stay tuned and we will give other notebooks and tutorials and attach the links into this video later. Okay, so before my introduction, I would like to briefly introduce myself a little bit. I am Liangyu, undergraduate research assistant from Information Engineering and Media, School of Electrical and Electronic Engineering, NTU. My research interests include data analytics, neural networks, as well as applications in medical and neuroscience fields. I am also an academic instructor at MLDA. If you have any problem regarding this tutorial, please send me email and I will try my best to explain it. MLDA at EEE is a new training lab that hosts all machine learning, data analytics, and artificial intelligence activities in the school. And Deep Learning Week is one of our featured events at this period. We are going to cover basic machine learning, neural networks, convolutional neural networks for computer vision, and also NLP and time series. So now we come to today's topic. What is NLP? Natural language processing. NLP is an area of computer science and artificial intelligence concerned with the interaction between machines and humans in natural language. What can be a natural language? Like English, what I'm speaking now, and also Chinese, Japanese, Hebrew, etc. The ultimate goal of NLP is to help computers understand languages as well as we do. Do you have experience talking to your digital assistant, like Siri on your iPhone? In the past, it was just impossible. From 1950s to 1970s, people have invented computers, but they are only to communicate with it via dotted paper tapes. After that, we invented command lines that enable us to communicate with machines in a way that humans can understand. But if you input such a sentence, I need a dinner reservation for Valentine's Day, definitely the computer will not understand what you are trying to say. But today, the situation is much different. If you say, I need a dinner reservation for Valentine's Day, your digital assistant will search any restaurant that has a table for one or not. These digital assistants are called conversational agents. Conversational agents like Google Assistant, Siri, Alexa contain functionalities like speech recognition. It could understand what you pronounce, language analysis, what you say, dialogue processing, how your dialogue comes so that it can catch the context in the conversation. And also information retrieval. Information retrieval basically is to Google to search it online and summarize the information that it got from online and return to the user. And finally, text-to-speech. It will return the results in a format of natural language that you will understand. In early 2011, an IBM computing system named Watson competed against the world's best Jeopardy! Champions. Watson was a famous intelligent agent that is capable for medical data analysis, and even before that, it was able to beat human in question-answering competitions. The Jeopardy! Competition includes questions like, where does divergent mean? What year was Lincoln born? And how many states were in the United States that year? This kind of competition requires the agent to be comparatively highly capable in its understanding of speech and information retrieval. Now, if we are looking at a closer application to our life, machine translation is a subfield of computational linguistics that is focused on translating text from one language to another. With the power of deep learning, neural machine translation has arisen as the most powerful algorithm to perform this task. This state-of-the-art algorithm is an application of deep learning in which massive datasets of translated sentences are used to train a model capable of translating between any two languages. Natural language processing has various applications and corresponding core technologies. For example, one of the applications is machine translation, as we mentioned, and also information retrieval, question answering, dialogue systems like conversational agents, and also information extraction. Information extraction is more of NLP and machine learning problem. It's more generic, where you train machine to extract hidden information from the raw text. Summarization, it could summarize the information that is retrieved, and separately sentiment analysis. Sentiment analysis is widely used in social sciences and marketing research. It could analyze the emotion of a certain sentence or the whole text based on the polarity of a word. For example, if I say, "Today I am happy," and the system will give a positive mark to my sentence as my sentiments. And if I say, "Today I'm not very fine," the system is going to give a negative score for my sentence. Core technologies. Language modeling is to determine the probability of the words that the sentence is going to say about. Part of speech tagging is to tag each word in a sentence based on their position in the sentence. Syntactic parsing, for example, natural language processing and also natural language processing is to divide the words into the correct order that the words and phrases are supposed to be. Named entity recognition, for example, Honda automobile. Honda automobile can be the entity of a brand, or even larger, it could be in the entity of an organization. Named entity recognition could help an NLP model understand the context of the text better, so it could better understand the meaning of the text. Word sense disambiguation. This is very interesting, and I could give you an example. I give a shot, whether I give a shot with a gun, or I give a shot with a camera, or I give a shot in a basketball game. A word in English could mean different things, but definitely a computer system could not understand without understanding its context. Word sense disambiguation is to find the exact meaning of a certain word in the text. Semantic role labeling, as you see from its name, is going to mark the semantic role of a word in the sentence. What does it mean from dictionary, and so what does it mean in this specific sentence? There are multiple levels of linguistic knowledge in NLP research, and we will go through the shallower layers to the deeper ones. From the shallowest depths, speech and text are what you see or what you hear. Phonetics, phonology, and orthography are the study of the speech or the writing system. Morphology is the study of the form of a certain things, and lexemes. Lexeme is to return the word into its original form. Like, for example, running, ran, their lemmas are wrong. Syntax. Natural language follows a certain standard of syntax, and NLP model will try to review the syntax of a text. Semantics. The NLP model will try to label the semantic role of each word or phrases in a text. Pragmatics. Pragmatics is a branch of linguistics dealing with language in use and the context in which it is used. And disclosure goes even deeper. It could suggest what the text is going to imply. Never mind if you don't understand these terms, we will review them later. Phonetics is the study and classification of speech sounds. Phonology is a system of contrastive relationships among the speech sounds that constitute the fundamental components of a language. At this step, the technology for an NLP model is to model the pronunciation that the user articulated. For example, E-R-S-A-N. These are meaningless articulations that cannot be perceived by a machine. But by capturing them, the machine could determine the probability that the user is going to say a certain word. Language modeling does similar things. It implies the words that the user wishes to say, and tokenization separates the words in a sentence. NLP models will also do spelling correction in this step. Morphology analysis. Morphology is a study of the form of the things. Sometimes the words are not in the original form, what we call lemma. Like, for example, the lemma of running and ran are both wrong. We need to process lemmatization for each word in the sentence so that the machine could understand them better, like the past tense, the present tense, or the future tense. Part of speech tagging. Part of speech tagging is to give a specific tag to each word in the sentence based on their position and their attributes. Syntactic parsing. Even though the position of a word is settled, their meaning can also vary based on their combination in the phrases. Syntactic parsing could combine the words into phrases for NLP models to understand the meaning of the text better. Semantics includes named entity recognition, word sense disambiguation, and semantic role labeling. Disclosure is a deeper part of the NLP model. It suggests what the sentence is going to imply or indicate internally. So where are we now in NLP? In 2016, there was a sci-fi film named Her. Her is a sci-fi film telling that in the near future, humans will be in love with artificial intelligence. By chance, the character fell in love with an AI system with great voice and great sense of humor. But unfortunately, humans are still far from this step right now. Usually the conversations with AI are going to end up in endless or meaningless conversations. And also, recently there are research based on the bias, especially the race and gender bias in NLP research. In 2016, there was a news that the Microsoft chatbot is suspicious to include a racist bias in its chatbot NLP model. And also, in 2017, there was related research on the gender bias amplification using corpus-level constraints. So why is NLP so hard? There are 6 reasons. Ambiguity. Sometimes the words can be ambiguous in natural language, although humans can understand it because we have a certain level of domain knowledge, but the machines cannot understand them certainly. Scale. Natural language are quite scalable. It can range from 1 sentence to millions of words. The frequency of words in natural languages do not follow a normal distribution or a Poisson distribution. It's highly sparse, and later I will show you a graph about that. Variation. Variation includes the variation of language formats based on occasions and also dialect. For example, the language that you are going to use for your FYP and the language you are going to message your friends are definitely 2 languages for the machine. Expressivity. Expressivity means a meaning could be expressed by different forms of language. Unmodeled variables. Some of the variables or words are unmodeled in NLP models. If I say, I drop a glass to the ground, it must break. But what if I drop a piece of plastic onto the ground? No, it won't break. So the NLP model should memorize the attributes for some variables, but now they are still unmodeled. Ambiguity at multiple levels may affect the performance of NLP models. Word sense. Bank. When bank comes to my mind, I would recall the financial institution where I would like to deposit or withdraw some money, but also the bank could mean the edge of a land near a river. Part of speech, chair, whether it's a noun or it's a verb. There is a tongue twister. Can you can a can as a can a can. So can you can a can? The first can is a modal verb. The second can is a verb, and the third can is a noun. The tongue twister at this moment is too hard for a machine to understand, but even simpler sentences can neither be understood. Syntactic structure. I can see a man with a telescope. So who is with a telescope? Whether it's I or a man. Multiple meanings. I made her dark. It could have different images as you see. One morning I shot an elephant in my pajamas. Whether it's to shoot with a gun, with a camera, or with your hands in a basketball game, we don't know. Ambiguity and scale differentiates with the language itself. For example, the ambiguity can be different from English to French or other Asian languages. And also that matters for different NLP technologies. So as you see, there are many challenges of words. Segmenting text. First, we segment text into words. We do morphological variation. The words are not always in their lemma. And we meet words with multiple meanings, as I mentioned, bank. And the words have their domain-specific meanings. The NLP model is also struggling to understand multi-word expressions, or what we call phrases in English. Make a decision, take out, or make up. Part of speech tagging. If you see such a sentence of message, you will definitely not understand what it's going to say. Actually, it's a code from WhatsApp Messenger. IKR is, I know, right? In this sentence, it is an interjection. SMH, shake my head, is an acronym. FIR is a misspelling word. It's actually for, so it's a preparation. Each word is marked with a part of speech in NLP models. Syntax. The words are ordered in a specific way. Syntax parsing is going to find the correct order in this context. Semantics. Every 15 minutes, a man in this country gives birth. And the next sentence is, our job is to find this woman and stab her. You could see that actually the meaning of a sentence is widely affected by the sentences around it. And even in a sentence itself, its meaning might vary. We saw the woman with the telescope wrapped in paper. So who has the telescope? We, or the woman? Who or what is wrapped in the paper? We, the woman, or the telescope? So how to deal with this ambiguity? How can we model ambiguity? In the past, there are some non-probabilistic methods like Koch-Younger-Kasami parsers for syntax that return all the possible analysis. And in modern times, probabilistic models like HMMs for part of speech tagging, PCFGs for syntax, and algorithms return the best possible analysis. In other words, the most possible one. It will calculate the possibility of each guess. But the best analysis is only good if our probabilities are accurate. Corpora. A corpus is a collection of text. It's often annotated in some way, and sometimes it's just simply a lot of text. For example, the Penn Tree Bank is a dataset of 1 million words of past Wall Street journals. Such corpora are the datasets for NLP models to train and validate. Statistical NLP. Like most other parts of AI, NLP is dominated by statistical methods in modern times. Typically, they are much more robust than rule-based methods that we used in the past. Relevant statistics are learned from data, as I mentioned, corpora or corpus. Normally, it requires lots of data about any particular phenomenon. Sparsity. English is a typical kind of sparse language due to Zipf's law. For example, the frequency of different words in a large text corpus are definitely different. If we order the words by their frequency, we will get such a graph. Variation. Suppose we train a part of speech tagger or a parser on the Wall Street Journal. There's a much greater intersection and integration of how to engage with consumers. What will happen if we try to use this tagger or parser for social media? It will be different. The languages are in their different forms when we speak in different occasions. And also the variation comes when we are talking about different languages and their dialects, expressivity, and unmodeled variables. The same meaning can be expressed with different forms. And unmodeled variables. I dropped the glass on the floor and it broke. I dropped the hammer on the glass and it will also break. No, it doesn't make any sense. Desiderate for NLP models today. First, the sensitivity to a wide range of phenomena and constraints in human language. And second, it should be general, across languages, modalities, genres, and styles. Strong formal guarantees, and most importantly, high accuracy, and it has to be ethical importance. In the past, before 1990s, people used logic-based or rule-based NLP to analyze their text. And after that, statistical NLP comes. And today, from mid-2010s, learned features and their representations come. We are able to analyze text with neural network we call recurrent neural network and also LSTM, long short-term memory. To make a comparison between NLP and machine learning, a machine learning needs bias and assumptions, but for NLP that may be linguistic theory or representations. NLP and linguistics. NLP must contend with natural language data as found in the world. And NLP is nearly equal to computational linguistics, which is a branch under linguistics, filled with connections to NLP. Nowadays, NLP is widely used not just in machine learning itself, but also linguistics, cognitive science, which is about how people perceive and understand things, and also how they form their emotions, information theory, how the information is transmitted, logic, data science, and social sciences like political science, psychology, economics, and also education. In today's applications, NLP is widely applied in conversational agents, information extraction and question answering agents, and so on. Factors changing NLP landscape. There are 4 factors that are changing NLP situation today very fast. First, increases in computing power, which allows people to apply neural networks into large data sets. The rise of the web, and especially the social web, provides a large corpora for NLP researchers to do data mining work. Advances in machine learning and advances in understanding of language in social context support NLP researchers to do their research. Okay, so that's all of the NLP introduction, and now I'm going to give you a very brief demonstration on the leading open source library for NLP. And please pay attention that if you don't have any prerequisite knowledge for Python, please go through our past workshops on Python and basic machine learning knowledge. So the library we are going to talk about is spaCy. There are actually many open source libraries like NLTK or scikit for scientific computation, but spaCy is the most easiest one for beginners. So we are going to start with it in our NLP journey. By the end of this demonstration, you will be able to use spaCy for basic text processing and pattern matching. spaCy is capable to take care of multiple languages, but even if your working language is not English, I suggest you begin with English. Here we import spaCy and create an English language model with a name of NLP. And we are going to process a text like tea is healthy and calming, don't you think? The first step of NLP modeling is to tokenize the sentence, which is going to separate the sentence into words. Tea is healthy and calming, comma. Here please pay attention that don't in the sentence are actually 2 words, do and not. Here spaCy has done this for us, and you think, question mark. But that's not enough. We are going to lemmatize the words. In this function, we are going to do some text preprocessing to lemmatize and identify stop words in the sentence. Like for tea is a noun, so it's not a stop word. Is a be verb or a modal verb, so it's a stop word actually. So the stop words are words that occur frequently in the language but don't contain much information. For example, the, is, and, but, and not. There are also other stop words, like do or not, and you, a pronoun. It's also a kind of stop words. Pattern matching is to check whether a text matches the terminology list or not. Here we import phrase matcher from spaCy.matcher, and we create a phrase matcher instance and define the term list. Here we import the text that we are going to use and apply matcher to this text. Finally, it will return the result of the pattern matching. Okay, so now let's try some basic text classification with spaCy. First, we import pandas and import the CSV file, which includes our text and a label signifying whether it's a ham or a spam message. Like for example, the message 0 is a ham, like it's a normal message, while for message 9, it's a spam message. Here we come with a technology called bag of words. So bag of words is very easy to understand from its name, is to package the words into vectors. For example, we define the vocabulary in the sentences tea is life, tea is love, and tea is healthy, calming, and delicious. The vocabulary then is tea is life, love, healthy, calming, and delicious. So V1, which is a vector for the first sentence, is going to be like this because it contains 2 times of tea and 2 times of is, and also the second vector for the second sentence. This is called the bag of words representation. It reveals the times that a word appears in a sentence. And you could also do that in TF-IDF, but what is slightly different is that in TF-IDF, we don't apply the vector to a sentence, but to the whole text, or we say the whole corpus. So now we build a bag of words model with spaCy, import spaCy, create a model, and create a text categorizer with inclusive classes and BOW, which is bag of words architecture. Here, please pay attention. We are going to add two labels named ham and spam to the text classifier. So now you will see that for each text record, it will have a corresponding label for ham and spam, both of them. So if it's a ham, their label for ham should be true, and their label for spam should be false. Here comes the exciting part. We are going to apply a machine learning model on our NLP instance. First, create an optimizer. If you don't know what optimizer is, please go to the machine learning basics tutorial, and you will know all the training and validation steps of a neural network. From spaCy.util import mini batch, and we create an optimizer. We set the batch size to 8 for our training, and then the NLP machine learning model is going to update itself in a batch size of 8 and set with our preset optimizer. So after you train your model, you are capable to make predictions based on your model. Here we import a new text for our testing, and we apply textcat, which is our trained model, to get the predicted results, the scores. So you could see that for the first sentence, the first score is very high, nearly 1, and the second score is much lower, which is nearly 0. So it means that its labels for ham is true, and its label for spam is false. And for the second sentence, its label for ham is false, and its label for spam is true. So after we label it, we have got the result of the prediction. So guys, thank you for your listening, and that's the end of our whole NLP tutorial. And I hope you enjoy it. In case that you have any question, please feel free to email me, and stay tuned. We also have computer vision and time series track. Please watch it. Thank you.